For this video, I'm going to do 3 examples of Pythagoras inside circles, and they're all past paper examples, so we're going to do 3 of these. First one is the 2015 past paper 2, question 12. So the diagram shows the cross-section of a milk tank. The radius of the circle centre O is 1.2 metres, so we know the radius, that's useful. The width of the surface of the milk in the tank represented by ml is 1.8 metres, so ml, we've got that, so we know that that's 1.8, so we can just write that in, 1.8 metres. Calculate the depth of the milk. So quite often if you see this shape where you have a circle cut by a chord, you're instantly thinking with that shape, if you've been asked to find some length, that you're going to create a right angled triangle using the radius. So I'm going to do exactly that. We're trying to get the depth of the milk. So this, from the centre to the bottom, we already know, because we've been told the radius, that's 1.2 metres. It's just this bit here that we need to try and find, this little bit here. So we draw a right angled triangle using the radius. This is what you're looking out for in these types of questions, where you can draw a right angled triangle using the radius, because we know the length of the radius is 1.2. It's the same as down here. And so this here, we know is a right angle because we've split this in half using the radius. So we've got this right angle triangle to the chord. Right, let's draw out this right angle triangle here that we've got. So we've split this in half, which means this bit of the right angle triangle is just going to be 0.9 metres. We've got the radius 1.2 metres, and then we're just trying to find this little bit here, which I'm going to label A. So we know using Pythagoras, we can find the length of one of these short sides by doing A squared equals the hypotenuse, which is C squared, minus the other short side squared. So A squared equals, our hypotenuse is 1.2, so we've got 1.2 squared minus 0.9 squared. So A squared equals 1.2 squared minus 0.9 squared, which is 0.63. And so A, therefore, is the square root of that, square root of the answer. We've got 0.793 ... which I'm going to round to 0.8. 0.8 metres. And that's us found this distance here, 0.8 metres. So we already had the radius, we've now got this 0.8, so the depth of the milk is going to be 1.2 plus 0.8, which is 2 metres. And that's you, we've used Pythagoras inside the circle. We're going to use the same sort of process for each question now. So next one, we've got 2014 past paper. Again, you can already see we have this shape where we have a circle and it's been cut into a chord. We're being asked to find a length, so instantly we are thinking Pythagoras theorem. So the diagram below shows a circle, centre C. The radius of the circle is 15 centimetres. So again, we need to use that in a moment. A is a midpoint of the chord P and Q. The length of AB is 27 centimetres. Calculate the length of PQ. So we're trying to get the length PQ. All right, so we know that from A to B, so all the way along here, A to B is 27 centimetres. We know that the radius is 15 centimetres, so we can just write that in here, which would be C to B. We also know that we can get the radius by going from the centre to the point of the chord, which is what we're generally going to do with these. So that one there is also 15 centimetres. You've created your right angle there because you've had this line splitting this one in half. And so we've got 15 centimetres. We're trying to find the length of PQ. So within that triangle, if we can find AQ, we can then double it to find the whole thing. So all we need is the length of this one here. We know that all the way along is 27 centimetres. The radius is 15, so this little bit here must be 27 minus 15. So we've got 12 centimetres there. So just drawing out that triangle like we did before. So I've got right angle there, 12 centimetres, 15 centimetres, and I'll just call this one A for now. So it's one of the shorter sides again, so A squared equals the hypotenuse squared, C squared minus B squared. A squared equals 15 squared minus 12 squared. A squared equals 15 squared minus 12 squared, which is 81. And therefore A must be the square root of 81, which we know is 9 centimetres. So we found this length here, 9 centimetres. In the question we were asked for the length of PQ. PQ is double that, so PQ is 9 times 2, so 18 centimetres. And that's you. We're going to do one more. This last one is a little bit trickier, so we're going to have to use some knowledge from other topics as well. So a cylindrical pipe has water in it as shown. So this is from the 2013 specimen paper. The depth of the water at its deepest point is 5 centimetres. So if we've got this water here at its deepest point, so this bit right in the middle, that's 5 centimetres. So you can mark it in if it helps. 5 centimetres there. The width of the water surface AB is 18 centimetres, so we could mark that in. I'm going to just leave that for now, 18 centimetres. The radius of the pipe is r centimetres, so we don't actually have a number, we've actually just got a term, so r centimetres. The distance from the centre O of the pipe to the water surface is x, so they've marked that in for us, x there. Write down an expression for x in terms of r. A little bit different this time. So write down an expression for x. So you know it's going to be an expression for x as in x equals something. And it needs to be in terms of r. So r is the radius. So what do we know about the radius in terms of x? Well, this whole distance is the radius. X must be the radius, subtract that 5 that we've got there. So that can be our expression. X equals the radius minus 5. So we have our expression x equals r minus 5. Next one, calculate r, the radius of the pipe. So let's look at what we've got. Again, we know we're looking for a length. We've got that circle with the chord. So you're instantly thinking what I was talking about before, where we have this right angled triangle created with the radius. So let's just draw this triangle out at the bottom and see what we can do to find our missing side. So looking back up here, the hypotenuse is the radius, so that's r. AB, the whole way along, we were told was 18 centimetres. So our section, the triangle, is going to be half of that, which is 9 centimetres. And this bit here is x, but if we have two unknowns, r and x, we're not going to be able to solve it. But we do know what x is in terms of r, so we can write in r minus 5 for that instead of x. Now our only unknown within this is r. When you've got one unknown, we will be able to find it using an equation. So we've got c squared equals a squared plus b squared. So let's substitute that in. C, the hypotenuse, is r squared, equals a, let's use r minus 5 first. So r minus 5 squared, and remember to put it in brackets, plus 9 squared. So we need to multiply that one out. You've got a double bracket. R squared equals, let's just do this at the side so I've got enough space when I'm writing. R squared is r minus 5 times r minus 5. So that becomes r squared minus 5r minus 5r plus 25. If you want to pause for a second and just check where I got that from, you can. Equals r squared minus 10r plus 25. So let's substitute that back in. R squared minus 10r plus 25. Plus this 9 squared, which we still have, which is plus 81. So let's just tidy up this plus 25 and the 81, and then we'll start moving everything over to one side. So r squared equals r squared minus 10r plus 25 plus 81. So 106. Now we've got r squared and r, so we want to move everything over to one side so that we can see what we've got. So moving all of this over, we would still have this r squared, subtract r squared from both sides, add 10r to both sides, subtract 106, equals 0. So actually what we've got now, we don't need to move everything over because actually these two, r squared minus r squared, that's gone. So all we have is 10r minus 106 equals 0. So we don't actually need to use a quadratic. We can just solve this by saying 10r equals 106, moving the 106 back over by adding 106 to both sides. So r equals 106 divided by 10, 10.6 centimetres. And that's you solved the radius of the pipe. And so that's you ready to look at some Pythagoras inside circle questions.